Morning everyone, it's me Ashita Pandey. So I will doing a demonstration of coursework one exploitation for that I have done for the course exploit element course. So we have gotten a zip file. After unzipping, we get the coursework one file as well as the coursework one patch file. So let's look at the coursework one file and let's check this file. So we need to patch this file in order to get the output that for the exploit. So there's also Docker file here. So I have already run the Docker in the background. So let's get a shell for this Docker and let's do the LDD. So we need to copy this libc.sod libc file and the LD file. Let's exit from here. So we can use a command like to sudo docker copy like this, and it will print on the local directory. I have already done it, so no need to done it. So there's another and a command for patching this file. So we need to do something like this. So for doing, we'll get the patch file as well as a solve file. So this is a simple demonstration, simple Python script that can be used as reference. So let's look at the coursework one patch file. So this is the patch file. It is not stripped, so it helps us for gaining the buffer here. So let's look at the pawn 6 cell. Also do the read elf. So there is the entry point address. So there is the function types here. So we need to manually inspect every each element here. So we can use a Gidra here. So this the vulnerability that has been provided for this coursework. Let's the user input return directly to the buffer without proper validation or any checking whatsoever, which causes a classical buffer overflow. So in this create file index, we can see there is the target size here and the local 40, and it gives us a value here. And so it so the input checks here are insufficient, and it and it helps us for the overflow. Let's look at the edit buffer here. Edit into buffer. So there is the edit into buffer. So in this here local 20, it also gives us the local value, and it gives us the file buffer plus local value times 8 byte, and this tries it directly to a memory location without verifying whether that local 20 has bits more than allocated. And this here is how it reads. So let's look at the last function here, and that is into read into buffer. So here is that. As you can see, it also gives us random value, and the buffer 50 size is necessarily validated, which also which also validated against the buffer size. The exploitation of such a vulnerability leads to arbitrary code execution and causes system crash, as well as gets the unauthorized access to the machine. So the three vulnerabilities were found in the edit buffer, read into buffer, and create file index. All this buffer use the read function to accept whether any user input are properly validated. So I have crafted the exploit value here. So, so let's look at that. So the system market is AMD, and I've used debug for debugging purposes. So this is for the file manager. So first I'll show you how the file manager works. So we can create a file in the slot 0, random value. So it has, so the max value has filled. So let's clear this. So let's look at the exploitation code here. So we have connected to the remote Docker shell here. So we have given this direct effect we have found on the while doing the GitHub, while doing the Gitra, sorry, while doing the Gitra. So our memory allocation is performed here to leak heap memory addresses, calculating the, and next step we calculate the heap base addresses here. The second option here. So the third is we use a null byte function. Null byte overcorrupts the chunk size to force heap values. This lets us use that heap chunks that is available. At the fourth section here, we exploit the heap metadatabase by corrupting to place the chunk in an unsorted bin, which enables the leakage of a sleep address from the heap memory. So the fifth section contains the earlier leak address, and it uses the stack memory address, and it is very critical for allocating the further exploitation part. So in the sixth path here, we create a read capability that tests the binary.txt section file and provides us the knowledge of executable section of memory. At the seventh path here, we over control the heap allocation with the malloc hook address with 1 point rope gadget, and it leads us to the cell execution here. So at the ninth place, we add a simple heap allocation that grants us a code execution and sponsor cells for us. So the exploitation technique works as we use the heap meta database manipulation to get a null byte overflow, and the function hook address overrides the malloc hook address and an arbitrary code execution resulting in the cell access. So let's look how it's done. So this was run on debug. So there is the 0x effort value size here, and we have put the null values memory somewhere memory there, and it gives us a interactive cell. So let's look at who id, who am I, the root. So let's ldd. So this file was on when we logged into the Docker file. So this provides us that we have successfully completed the code execution yet and resulted in a successful exploitation of the of this part. Thank you very much.